Good afternoon. The next speaker is Lisa Messeri, which is associate professor of anthropology at Yale University. She just published a book which title is Placing Outer Space, so you can find it on the internet or in a bookshop. So please, Lisa.
Thank you all for coming. So did you guys just go on a tour of the biosphere before this? So it's an incredible site. And we've been privileged to actually spend the night here, not in the habitat. That was not a great thing that happened, but just in the dormitories outside. And we've kind of spent the last yesterday and today, a group of scientists and anthropologists really trying to understand how it is that we comprehend the cosmos, right? It's this like incredibly vast thing that we all really live in, right? We live in outer space. We're on this little planet kind of jetting through the air. So how do we just kind of comprehend the magnitude and the awesomeness of what it means to kind of be humans on Earth? That's a question that you can't just answer from one discipline. You can't just get a scientific answer for it. You need historians and anthropologists and sociologists and psychologists to chime in as well. So what you're going to hear today is first my perspective as a historian and anthropologist before hearing kind of the scientific flip side. So I'm going to kind of set the social and human stage, and the conversation will go on from there. So the title of my talk is Being Elsewhere, Analog Fieldwork and the Planetary Imagination. So I imagine many of you in high school, who has taken a history class? Raise your hand, yes, good, audience participation. So you've taken a history class, so you kind of know that history is the study of our past, right? How many of you have taken an anthropology class? We have a couple, so would someone like to volunteer what anthropology is? Who just raised their hand? Yes, please. Yes, you got it, come on.
Study of the human.
Yeah. Study of humans, right? Anthropology writ large is the study of humans. Anthro at the front means human, and it's the study of humans in all of their various ways, our bone structure, our language, the things we use. I am a cultural anthropologist, which means that I study the culture of humans. I study why it is that we talk to each other in particular ways, why it is that we all believe in the same things and don't believe in other things. This field has historically been the study of people not like us in this room, not kind of Western or American or European cultures. It's historically been about far-flung, exotic cultures, people that don't look like us, that don't talk like us, that don't act like us, this kind of other specimen. In more recent years, anthropology has tried to do the exact same thing we did with these kind of other cultures and communities to ourselves, to subject Western cultures to the study of anthropology. So as a cultural anthropologist, I study the rarest of all tribes, scientists. Now, I don't know if you've ever met a scientist. They hide underneath rocks. They're very hard to get to. You have to travel large realms to get to them. But I wonder, what is the culture of science? How do scientists make meaning in what they do? So what I'm going to talk to you about today is a very particular set of scientists. And these are all scientists who do what I'm calling analog fieldwork. So again, another term that you're probably familiar with is analogy, right? This is to, analogy is trying to take something that you're not so familiar with something you're familiar with, to make the connection so you can know the mysterious. So with the idea of analog fieldwork is it's kind of using this idea of analogy to make sense of places that we don't know based on our experiences with places that we do know. So this idea of analog fieldwork is one way I'm going to show you how historically, from the time of Apollo astronauts to contemporary scientists today, analog fieldwork has been a way for scientists to understand what outer space is like, what the moon is like, and what Mars is like. So let's start in a particular place on Earth. So how many of you does anyone recognize what this is? Yes?
It's a crater from the meteor crash, like on
Not the dinosaurs, but it is Meteor Crater. So this is Meteor Crater just north of you in outside of Flagstaff, Arizona. So how many of you have been to Meteor Crater? Oh, okay, only a couple of you. This is like, I don't know, maybe a 6-hour drive. So super close. I'm sure you'll get there one day. I had never been to Meteor Crater. At the beginning of January, I was driving cross country from where I normally live in Connecticut to Los Angeles, where I'm spending some time doing research. And every morning I would wake up and kind of look at where to get off the road, what would kind of break up this cross country journey. And as I was driving from Albuquerque to Phoenix, I was looking up the route I was going to travel that morning from my hotel breakfast bar, and I saw a little marker for Meteor Crater. And I was so excited because I have actually written a lot about Meteor Crater. I had studied the history of the crater, the people who went there, but I had never actually been there. So I kind of detoured my route that day to take a visit to Meteor Crater. So what is Meteor Crater? Meteor Crater is this privately owned crater that you enter only after paying an entrance fee. The crater, as you can maybe see, is 1 mile in diameter and is advertised as the first confirmed and best preserved impact crater. This was first studied, the first major book about Meteor Crater was from the mid-20th century, written by Eugene Shoemaker, who was a geologist working for the U.S. Geological Survey. And he was able to prove that this crater was not formed by a volcano erupting, which is how many geologists believe this crater and other craters on Earth were formed, but rather it was from the impact of a meteor. And so Eugene Shoemaker, along with collaborators in the future, would go on to find the crater of the meteor that they thought was the extinction of the dinosaurs in the Gulf of Mexico. But this was the first one found so large and above ground that it could actually be studied. And what's so amazing about this is that it is these impact craters that are on Earth that are actually formed in the same way as craters on the moon and on Mars. So this place became somewhere that you can go to and begin to imagine what it might be like to stand on the rim of a crater not on Earth, but on the moon or on Mars. So Shoemaker began studying this crater in the mid-20th century, and he even founded this branch called astrogeology, trying to take the principles of geology to bring them into the world of to astronomy. And he moved the headquarters of this branch that he founded in the 1950s from California to Flagstaff, Arizona, to, among other things, be closer to Meteor Crater and to further study it. Also during this time period, Shoemaker successfully petitioned NASA to allow him and his staff to train test pilots turned astronauts to study geology, such that the soon-to-be trips to the moon would have scientific value in addition to the cultural and political value of the space race. At Meteor Crater today, and you should all visit, the admission to the site includes a tour by a guide who walks a small group around the crater of the rim. My guide a few weeks ago was named Bill, and he was very knowledgeable and eager to talk about the history and the geology of the site. However, I was disappointed that by the tour's end, he had only mentioned astronaut training in passing, and that's of course what I was so excited to go to this site for. As we were walking back to the visitor center, retracing our path along the rim, I asked Bill to discuss this period of the crater's history. So the astronauts trained here because Shoemaker had already studied it. I prompted Bill, and he agreed, and then went on to tell me about another site of astronaut training closer to Flagstaff, a site that I had also wanted to visit, but when I was Googling how to get there, you needed a 4-wheel drive vehicle, and my Honda Fit did not count, so I had to cross that one off the list. However, at this site that Bill was very excited about, he said that the folks that Shoemaker worked with at the Geological Survey in the 1960s had created a crater field to match the Sea of Tranquility, the site where Apollo 11 would land. The guide told me that he likes to go camping there. It's a weird place. You feel like you're on another planet. I smiled and thanked Bill for the tour. So for the past decade, as an anthropologist, I have been thinking and writing about the idea of place and what it means to imagine being on another planet. Bill's statement really captures the puzzle that's been at the heart of my research and my writing. How does a place on Earth become weird, such that it begins to feel like you are no longer on Earth? On the other hand, how does the Moon or Mars feel familiar enough that this weirdness melts into a feeling of being elsewhere? To say that it feels like you're on another planet, as Bill did, suggests that one knows what being on another planet is like. And further, that being on another planet would be not so different from being in a weird place on this planet. This is a cover of my book club, book plug, Amazon.com, $24.99. So my book, Placing Outer Space, it explores these questions of how scientists transform planets from data into worlds. So how do planets become these things looked at through telescopes or streamed in through computers that are very complex and messy? How do they stop being these just scientific things and start being worlds, these intimately imagined places? How does our neighboring Mars or distant exoplanets, planets around other stars, become places that scientists can actually imagine stepping foot on? For this talk, I'm going to focus on one placemaking technique, analog fieldwork, which I already began to introduce you to. This is a particularly fitting topic to discuss at Biosphere 2 because Biosphere 2 is itself meant to be an analog of Earth, meant to stand in for all the complex things that that might be going on in Earth's biosphere. I'm going to discuss how it happens that Earth is made similar to other worlds, and how fieldwork becomes a way to scientifically know and experience other planets. Fieldwork becomes this thing that even if you never leave Earth, you might feel and begin to believe that you're on another world. I'm going to begin kind of with a historical story explaining how geology, a science of Earth, became a science for all of the cosmos. This was a conceptual shift that helped it seem natural that visitors to the moon should learn to do geology. I'll then turn to the Mars Desert Research Station, a site which, like the biosphere, aspires to capture elements of a whole planet in a microcosm of a single site. This is a space in Utah that I'll talk more about, which is a simulation of an early settlement on Mars. During my own visit to this site with a crew of NASA scientists, we imagined what it might be like to do geology not on Earth or in Utah, but on Mars. I'm going to explain how this analog fieldwork facilitates moments of feeling physically transported to Mars and all of the excitement that entails. I'm going to conclude at the very end by thinking about the significance of the frontier in the planetary imagination and invite us to brainstorm what other analogies might be used to inspire future endeavors of humans in space. But let me begin with the historical moment. How did geology become a lunar science? All right, so here's an image and it has a caption, but can someone just tell me what they see in this? Like can you describe this picture for me? I heard dirt. Great. Yes, there is dirt here. What's happening in this picture? Can you make sense of it?
Science.
Science is happening. This is science. Why do you think it's science? What tells you that it is?
They're digging into the dirt looking for some valuable minerals and whatnot.
Yeah, so we see them digging, they seem to be discussing, there's these things attached to their chests. What are those things? Camera, so they must be documenting. So, and they're kind of digging and they're exploring. Now, as the caption shows, these are astronauts. This is what astronauts do when they're not in space. This is a training run for two Apollo 15 astronauts, Jim Irwin and Dave Scott, just outside of New Mexico in March of 1971. The canyon in the background is standing in for Hadley Rill, a location or a feature of Mars that these astronauts will one day be standing near on the moon. So this was an attempt to make them feel like they were already on the moon in order to do some training such that when they arrived at the moon, it would feel a bit familiar. So astronauts, we don't necessarily always think of them as geologists or scientists. They were all test pilots. They had the most bravado. They were the bravest. They were selected for their right stuff. So how on earth did these folks selected for their right stuff get saddled? We're walking around the New Mexican desert saddled with mock lunar equipment identifying basalts. How did these jocks get turned into nerds? How did geology, in other words, become a discipline for uncovering not only the story of Earth, but also the story of the moon and other planets? And in order to answer this question, we actually have to take a historical approach to this. This is actually a mid-20th century debate about how it is best to know other places. This debate paved the way for the legitimization of geology beyond Earth, the astronaut fieldwork training that we see here, and also the later astrogeological analog fieldwork activities practiced today that we'll talk about with regard to Mars. So, modern geology did not always exist, but it emerged in the beginning of the 19th century and was established as the study of Earth, only our planet. Its application to Moon or Mars was in fact not initially intended, and not all geologists were in favor of expanding the scope of their discipline. So what I'm going to show you now is a bit of a debate that geologists had with each other over the course of several decades about whether geology is actually applicable to places beyond Earth. So it was first perhaps proposed in 1938 by a scientist who very tentatively, and in fact with apologies, suggested that geology maybe, perhaps, he said, has something to offer selenology, or the study of the moon. This was kind of politely dismissed, and the issue was dropped for a couple more decades. However, as solar system science became more established as the 20th century progressed, two scientists suggested in 1960 that distinguishing selenology from geology set a dangerous precedent of coining a field and associated term for each planet in the solar system. Instead, they argued, geology and the geo term can be extended from their earthly meaning to cover similar processes and features on other cosmic bodies. Wherever they occur, a caldera is a caldera, a sulfur is sulfur, and a reverse fault is a reverse fault. Geology, they argue, was not tied to Earth, but perhaps it was what tied Earth to other planets. So what I'm trying to show you here, to take you inside some of these scientific conversations, is maybe today it seems obvious that we can use geology on Mars. There was a moment not too long ago that was hotly debated amongst these scientists. This is this idea that science and what science is changes and evolves, that it's constantly revising itself, and that scientists, in fact, get very passionate and kind of debate nicely in the pages of journals over these topics. So it was also in the 1960s, right when these kind of claims were being made, that Eugene Shoemaker established the astrogeology branch of the USGS, and Shoemaker was a real advocate for space science. He himself wanted to be an astronaut, but he had a very small health deficiency which kept him from going to the astronaut program. So he thought if he couldn't be an astronaut, he would at least try to get the other things he loved, which was geology, into the mindset of NASA as they began to collect their astronaut corps and plan for missions to the moon. Initially, what Shoemaker was doing some of the early maps of the moon, looking for potential landing sites that weren't too cratered, and he would go on to head the astronaut training. But because because American geologists were starting to make a claim that geology belonged on the moon, some of them were getting a little bit nervous that their field was going to be co-opted by Shoemaker and his ilk, and that people would actually kind of stop doing geology of Earth because it was going to be so much more exciting to do geology of the moon and Mars. So there were a couple geologists that really were pushing against it, saying that no, geology can't be a science for everything. It's only a science for Earth. So there was a geologist from the University of Helsinki who in 1962 said, well, I, for one, am taking very strong exception to the use of geology in planetary geology, lunar geology, and astrogeology. What he goes on to say is that clearly geology is restricted to the study of Earth and of terrestrial phenomena and does not apply to extraterrestrial bodies and processes. Another set of scientists retorted that no, this guy is wrong. Geology is not about Earth with a capital E, but about Earth with a lowercase e. In a short piece, an American scientist wrote, it is this idea of the solidity, the stability of the land on which we can land, at which we can safely land after travel through a more precarious medium, and it is the rock that composes this land. So this is a scientist trying to say it is that Earth with a small e that we find ourselves on that is the product, that is what geology can tell us about. The scientist concluded, geology will be the study of the place where they land. And indeed, after landing on the moon, the astronauts, and after astronauts received this geologic training, in large part due to the efforts of Shoemaker at the USGS, there was very little hope for these dissenters to keep geology grounded on Earth. In a presidential address to the geologists of the Geological Society of America in 1970, the president, Morgan Davis, began by declaring the year the most momentous year that the geological profession has ever had. I refer, of course, to the landing of on the moon. So he had used this opportunity as the president of all the geologists of America to say, you know, step in line. The astrogeology group has won. Geology should now be embraced as a science beyond Earth. So the flourishing of the USGS's astrogeology branch helped legitimize geology as a multiplanetary science. When, in 1963, the branch moved from its original offices in Menlo Park, California, to Flagstaff, not too far from Meteor Crater. And it was also in this year that Shoemaker began to train astronauts in lunar geology. So the astronaut training began in 1963. So we're going to we need to remember what 1963 was like. I mean, you all remember 1963, right? Oh yeah, it was crazy. But from the perspective of human spaceflight, let's go back a little bit further. So does anyone know who the first person in space was?
Yuri Gagarin.
Yuri Gagarin. So Yuri Gagarin, the Russians, the Ruskies, they beat us. Yuri Gagarin was the first man in space, and he orbited Earth in 1961. Who was the first person on the moon?
Neil Armstrong.
Neil Armstrong. And Neil Armstrong landed in 1969. 1961 to 1969 is how long it took to go from sending any person in space to landing someone on the moon. That's a really incredible 8-year span in which we went from never having anyone in space to going as far as we've ever been in space. So the astronaut training began in 1963. And I just like think about that moment. The Russians were beating the US in the space race for almost the whole time of the space race. We really thought the Russians would be there first, that communism would take over the world, that everything would be terrible. And so there was a lot of bravado happening at this time in the space race. So this was in 1963 when Shoemaker was like, hey, let's do a geology class. All of the astronauts were excited. There was bravado and adrenaline and testosterone running around the astronaut corps. It was very audacious for Shoemaker to take his team of lunar scientists and geologists and teach these test pilots turned astronauts that there was more to know about craters than simply how to avoid landing in them. But that was exactly what the goal was. So traditional geology is a field science, and geologists train by going to field school. So this is getting back to this idea of field work. And they learn kind of particular regions that they go back and study again and again. So the USGS training team faced a problem. These were the team that was charged with training the astronauts. How do you teach someone to be a geologist before they have stepped foot on the terrain they were going to study? If geology was premised on the fact that you learn geology by going to the field and seeing rocks and studying them, how do you learn to do geology if you can't go to the place you're gonna study? So to teach fighter pilots how to identify rocks and make sense of their lunar surroundings, the USGS ran all these mini field schools for the astronauts. After all, as one member of the astrogeology branch put it, fieldwork is the essence of geology. It really is. You don't get any sense of complexity of geology until you go out and try to do it. So Shoemaker and his colleagues all received this extensive fieldwork training in their geology educations and wished to impart this on the astronauts. Shoemaker wanted them to come out to Arizona, where the canyons and craters made ideal training grounds. He recalled his plan to, quote, get astronauts away from their day-to-day involvement in the space program and all of the other activities that the astronauts had, deorbit them for a while, and get them on the ground and give them 3 months, and that's an incredible amount of time, 3 months of really solid training, which is what it takes. You have to go out and do field work to learn how to do field work. And I love this picture because it's Neil Armstrong on a donkey in the Grand Canyon, which is really special. So the aspiration behind astronaut training was not only to get them to see like geologists, but also to teach them how to compare what they saw on Earth to what they would see on the moon. It was a move to place the terrestrial landscape on a different world. And in fact, the training was so intense that several astronauts, after they got back from the moon, commented on how much the moon's surface looked like their memory of field training on Earth. So the moon began to look like Earth for these astronauts trained in geology. As the Apollo geology training program progressed, the U.S. geologists decided that these analog sites like Meteor Crater and that ridge just weren't really doing it. They instead decided to craft their own ideal lunar landscape. So after carefully studying the photographs of the landing site for Apollo 11, which was going to be where Neil Armstrong would soon land, they placed a series of explosives in a field outside of Flagstaff, Arizona, and then detonated it in order to look at like the exact crater placement that they would soon be landing on the moon. The idea was that being in these analog so that we can see how these analogies work in both ways. It's not only that Earth, it might naturally seem like the moon, but we can also make it seem even more like the moon. It's through these fieldwork practices that Earth got refashioned as the moon, and therefore scientists could learn to make scientific sense of the lunar surface. So if you can't get to the moon, let's bring the moon to us. So returning to this image, maybe what at first seemed a bit jarring, trying to understand what this was, is it science, is it training? We now kind of can understand it a little bit more. We understand that what's behind this image of astronauts training is this understanding that was not always obvious, that geology should be something that the astronaut knew and could bring with them as they traveled into space. We now understand that what we see here are astronauts pretending to be on the moon while still being on Earth. We learn that the Earth can stand for other planetary places, and this is something that scientists today are still imagining. Scientists today still imagine Earth as a variety of different planetary sites. So fieldwork, which we're seeing these scientists do now, is in fact not only the essence of geology, but it's also the primary method of anthropology. So as an anthropologist, I spend actually less time in the archive looking at these cool photos than I do just simply hanging out with people I'm interested in studying, for example, other scientists. So when I heard several years ago that there was a place in Utah where scientists went to pretend to be on Mars, I really had to go there. So we're going to take our leave from the moon for a moment and go on to Mars. And we're going to learn about a site that was founded by the Mars Society, which is a nonprofit a nonprofit space advocacy organization that has a simulated Mars research station in Utah. I went there with a group of NASA scientists headed by Carol Stoker to understand why these scientists were continually going to this site in Utah and pretending to be on Mars. Carol Stoker, who was my lead, ends up being is actually a founder of the Mars Society, and became really instrumental into understanding what the goal of this particular group of scientists is. So the Mars Society. The Mars Society is, members of the Mars Society dream of going to the red planet. That is what they think is kind of a really important goal for humanity. Though Mars is, they write in their charter that the time has come for humanity to journey to Mars. We're ready. The Mars Society's most visible projects are its 2 analog research stations. There's one in the Arctic, but that was a little bit too cold for this anthropologist to want to go to. And so then there's this other one, the Mars Desert Research Station outside of the Utah desert. This station has been in operation since 2001. Crews of 6 go and occupy it for 2 weeks at a time. There's been over 180 crews here, and MDRS is currently in its 17th field station. In its field season. The occupants of MDRS are very varied. Some of them are NASA scientists, but some others are enthusiasts. They do various kinds of science projects as well as psychological studies or even occasionally an anthropological study. We all would sleep, cook, and run experiments in the habitat, or HAB, very similar to the language used here. And during the day, we would perform EVAs, borrowing the NASA term for extravehicular activities. So on these EVAs, which is pictured here, we would heighten the simulation by wearing spacesuits. So these are not exactly NASA-regulated spacesuits, but instead are fashioned out of flight suits and plexiglass and trash cans. Very high tech. The mission that I was on was trying to test equipment for a future Mars robotic drill. Stoker, my host, had earned her PhD in astrogeophysics from University of Colorado in 1983. As a student, she had quickly made friends with those like her who were inspired by the Viking images of Mars and were disappointed by NASA's inability to mount a human mission to the red planet. After years of plotting and thinking about exploring Mars amongst themselves, they began convening this conference in the early 80s called The Case for Mars. At this conference, a group called the Mars Underground kind of convened and made itself known as an advocacy group, and this is what eventually the Mars Society grew out of. And this is a banner from the early days of the Mars Underground, and when I visited Carol Stoker at her offices in NASA Ames, it was hanging from her walls. So this kind of early days of her career still are really important to her and how she understands her science that she does. So these Case for Mars conferences happened every decade, and eventually Stoker and her colleagues joined with others to form the Mars Society, which went on to develop this Mars Desert Research Station. When Stoker decided to bring a crew to the Mars Desert Research Station, the Mars Society was facing financial troubles. It's kind of hard to keep this a nonprofit that hosts this Utah site open. So one of her purposes was actually to try to convince NASA that they should be giving money to the Mars Society, to the MDRS, to kind of keep it going, that you could do good science here. So MDRS is located in the Utah Red Desert outside the small town of Hanksville. The founder of the Mars Society, Robert Zubrin, selected this location after he met James Cameron. You might know, the director of Avatar or Titanic. Cameron is a huge Mars head. He really loves and believes in the human exploration of Mars, and he was actually working on creating an IMAX film when in scouting an IMAX film about Mars. When in scouting locations, he stumbled upon this location outside of Hanksville. A location scout told both Zubrin, the head of the Mars Society, and Cameron, it's Mars. So Zubrin agreed. This view of these striated red mounds of rock and rubble that make up MDRS environs, they've been a constant thrill to crews that have come to this site. As an early visitor to MDRS put it, quote, "This beautiful landscape is a glimpse of what a real Martian landscape might look like. It felt more than just a setting for a Mars simulation, a more accurate feeling, this is Mars." In addition to the landscape, the living and working environments at MDRS make crews feel like they are immersed in an otherworldly experience. Crews live in a cylindrical habitat outfitted as an early settlement on Mars might be. For many crews, wearing the simulated spacesuit is a crucial element of the simulation. The crew consensus was that before you suit up in the spacesuit, you are simply roughing it and trying to do some science on the side. Once you put on a suit and surrounded by this otherworldly scenery, everything becomes surreal. You are on another planet. So this is the part of the MDRS, this research station, that really interested me. How does one transition from being on Earth to being on Mars? How can one place come to stand for another? Unlike astronaut training, few visitors to MDRS think that they'll ever actually make it to Mars. This experience is the closest that they're going to come to being intrepid off-world explorers. For the crew that I was a part of, Stoker, perhaps acknowledging the inherent goofiness of wearing fake spacesuits and walking around the desert, decided that we would not wear these simulated spacesuits nor actively pretend to be on Mars in an effort to draw NASA's attention to the more kind of legitimate science aspects of this site. So if we weren't playing Mars, how would this desert ever cease to be terrestrial? I got very nervous. I wouldn't have anything to say. So most of our days were spent driving from the hab to different rock formations to test the drilling equipment and take soil samples. Stoker and I had collaborated on documentation procedures and were testing it one morning with two other members of the crew, Julia and Danny. It was a chilly day in late November, and after several hours of meticulous soil collection, I was incredibly pleased when Stoker said we could start packing up and head back to the warmth of the hab. As I was heading back to put our equipment away in the truck, I heard sounds of excitement coming from Stoker and Julia behind me. I returned to the site to see what they had discovered. Scattered across the ground, a few meters from where he'd been collecting, were hundreds of these little spherical rocks. Stoker and Julia eagerly, almost frantically collected samples, forgetting about the procedure we had worked on and simply grabbing these rocks and putting them in plastic bags. They were laughing and smiling, thrilled by these little rocks that to me seemed insignificant. Stoker looked satisfied and excited, exclaiming that exploration is fun. I tried to join in the excitement. What are these rocks? They're concretions, I was told. I responded enthusiastically, what are concretions? They're made of something, are they made of something special? Do they indicate something unique? The only response I got was a shrug, and Stoker and Julia went back to their frantic collecting, and I was left puzzled looking on. After this initial wave of excitement died down and we were just standing around enjoying the sight of the concretion field, I asked again why this was so exhilarating. These are like the blueberries on Mars, Stoker responded. Suddenly I understood what had happened. Whereas I was still standing in the Utah desert, Stoker and Julia were transported to Mars. Our fields, though overlapping moments before, had suddenly diverged. The moment I had come to Utah to witness and understand, when one place comes to stand for another, had happened without my realizing it. So these blueberries, as it turns out, were an incredibly significant finding from the Mars rover Opportunity, which is still roving on Mars, and maybe you remember reading news about it. So right after it had landed, it discovered these things on the right that the chief mission called blueberries, for lack of a better word, because they reminded the scientists of blueberries sticking out of a muffin. So after a bunch of studying and hypotheses, what they decided is that these were concretions, which occur when water, after a long period of geological time, when water has kind of taken away all the soft sediment and only the hard sediment remains in these spherical forms. So for the Mars scientists, this was incredibly exciting. One of the big questions has been, is there water on Mars? It seemed that these blueberries might be evidence that water one day existed on Mars, maybe even today. So that was just a huge finding from the Mars rovers. So going back to Utah and finding concretions, it was certainly an exciting discovery, but not because it confirmed that there was water on Earth. We were pretty confident of that finding. Rather, it offered Stoker, who knows a lot more about Martian geology than terrestrial geology, to find a connection to this landscape. Physically being in this landscape, which had numerous visual reminders of Mars, from the red-tinted desert to kind of the eeriness of it all, combined with the act of not merely seeing, but holding and collecting these concretions, were powerful reminders of Mars and led Stoker and Julia to an otherworldly experience, and one that I simply couldn't follow because I didn't know the significance of these concretions. They were no longer in Utah, but in fact exploring Mars. They shifted in a moment from performing terrestrial geology to performing planetary geology, and analog fieldwork therefore became space travel. So experiencing Utah as Mars sneaks up on MDRS participants. Consider this very similar account sent by a report from MDRS to their Mission Control, which is a group of Mars Society volunteers that the crews communicate with every day. This was a crew that came before I did, and the crew member writes, "All was triggered by a very special event in the afternoon, which switched my mind to Martian modus entirely and made me feel like a real astronaut on Mars." He goes on to write that he had finally landed on the red planet with both my mind and my heart. He talks about how 2 days previously had been dedicated to kind of exploring a particular part of Mars, where you could actually see the whole MDRS habitat. And he goes on to write that it was at this precious moment that I suddenly really felt like an astronaut on Mars, when I remembered the graphic of the astronaut standing at the edge of Valles Marineris with the rising sun in the back. And then suddenly the image switched, and in the very next moment, I was this astronaut. So in being on it, so for us, it was the concretions that triggered a feeling on Mars. For this participant, it was standing on this rim that the commander connected his embodied experience to this Martian feature, Valles Marineris, and the landscape ceased to be terrestrial. He had the sense of being on Mars. So, how geology became a backbone of planetary science, the ensuing geological training of astronauts at sites that were imagined as analogous to those we might encounter on the moon, and the continuation of this legacy as scientists and enthusiasts mentally and scientifically prepare for human exploration of Mars, delineates one axis along which we imagine life, human and otherwise, beyond Earth. The ambition of today's and yesterday's workshop for the scientists and anthropologists here has been to bring scientific and humanistic perspectives together. And so I'd like to conclude by suggesting one way in which knowing these historical and cultural stories can enhance our collective space futures. What I'm suggesting to conclude is that these stories of analog fieldwork and the creation of place in the seeming desolation of outer space emphasizes a powerful rhetoric that continues to dominate our space imaginings. And this is the rhetoric of the frontier. I'm one of many scholars who have suggested that we use this analogy only with caution, remembering not only the imagination of the intrepid cowboy, but also the exploitations of people and land that came with settling the frontier. So my intention here isn't to kind of be a spoil sport, but rather to inspire interdisciplinary collaborations to take seriously historical legacy, both its positive and its negative valences. So aspirational space travelers, be they Apollo astronaut recruits training in geology or participants of MDRS, are easily imagined by themselves and others as pioneers working at the edge of a frontier. It is significant that fieldwork I discussed here was performed in the American West, with the frontier landscape as the backdrop. The first astronauts spoke of themselves as pioneers ready to explore the space frontier. And this is one of my favorite images, as I think it really captures this idea of the astronaut cowboy, even though this is actually a geologist, not an astronaut, but wearing one of the early spacesuits. So in the 50s and 60s, kind of this is after the atomic bomb was dropped and kind of the romance of war had been shattered, I think the public was really excited to have something to be behind. And so there was something about the astronaut as the intrepid explorer, kind of a redeeming of the American narrative of conquest that kind of fell apart in the post-war period, that made people excited to embrace the reemergence of the frontier as how to make sense of spaceflight. So going going back even to Shoemaker, who trained these geologists, he also found the frontier a compelling analogy. He writes how he tried to draw at a science meeting an analogy between the early exploration of the American West and the Apollo program. The difference, of course, was the early exploration of the American West led to evolving, continuing, growing scientific enterprise. The Apollo program didn't. Famously, we went to the moon, we came back, and we haven't been back since. So even while the Apollo program was still going on, Shoemaker began to speak out against NASA's vision of exploration. He really thought that it should be scientific at its core, that we should continue to go back to the moon again and again and set it up as this frontier to help us eventually get to Mars. Now, the inhabitants of MDRS today are also imagining themselves as pioneers. And here's a couple quotations taken from some participants at MDRS that just kind of get to this frontier spirit. This experience of living and working in sim, being in the simulation, has made us feel like pioneers of a sort. We aren't doing groundbreaking research, nor have we truly gone anywhere, but we feel a sort of spiritual kinship with those who have. And from another one, we are here not for fame or glory, but out of curiosity. We want to know, we want to explore. We are pioneers and we're braving this new world, not only for ourselves, our families, and our country, but for all of humanity. Very grandiose for living in a sphere, in a cylinder for 2 weeks in Utah. The figure of the pioneer is primed not only by the earlier astronaut accounts, but also one of Mars Society's holy texts, Robert Zubrin's manifesto that's entitled The Significance of the Martian Frontier. This was first published in 1994 and makes unproblematic use of Frederick Turner's frontier thesis to argue that the human mission to Mars is the only way to salvage humanism. Basically, it says Mars beckons us, and it's the only way to save who we are as humanity. So there's problems with both Shoemaker's and Zubrin's use of the frontier, and historian Patricia Limerick has acutely pointed out the dangers of such a metaphor. If it is to be used, she argues, it should be used sincerely. It should acknowledge the oppression, wars, and diseases that went along with settling the western frontier. Moreover, it should make proponents of space exploration consider the implications of executing enterprises done with too much haste and grandstanding and with too little care for detail. Though the frontier metaphor could have been used as a checklist of problems to watch out for, it was instead used as a naive association that simplistically and uncritically constructed the pioneer. And I'm almost done. So the frontier rhetoric persists in both NASA and private space endeavors. It builds enthusiasm, but also suggests one particular way of making place in outer space. It suggests a mentality of settlement and conquering. And so what I wonder is if there are other imaginations of exploration and place that might inspire new scientific questions and reshape technological development. So what if, like the biosphere, we imagine outer space not as a frontier, but as an ecosystem? How would a systemic imagination of space inhabitation unfold? What if we weren't settling and conquering and pushing outward? Rather, what if we were already in the system we wish to study? So what I hope this talk has shown is that the moon and other planets aren't obviously places and destinations, but they are made so through human activity. Geologists had to argue that their science could be used to study the moon. Shoemaker had to convince NASA that astronauts needed to be trained as geologists. And crater fields in Arizona and sites in Utah must be specifically fashioned and inhabited to evoke this otherworldly feeling. All of these terrestrial activities reshape other planets as things like Earth, and thus argue that they too are places on which humans can and should be. And I will stop there and turn it over to the next speaker. Thank you.
Well, thank you very much. Fantastic talk.